What are stains? Well, stains are typically a form of substance that is either spilled or attached onto a material. The substance then becomes trapped within the material, producing an unwanted discoloration. For example, have you ever accidentally dropped some chocolate on your shirt, and before you realize what happened, the chocolate had already melted into your shirt? Well, that's an example of a stain. Stains can be classified into four generalized groups. The first group is called enzymatic stain. These stains usually contain proteins, fats, starches, and oils. The second group of stains is the oxidizable stains. These stains are usually cleaned by bleaches. Not only do they disinfect, but they also put the stain through a process called oxidation, which I will explain later. The third category of stains are called greasy stains. As you can tell from the name, grease stains are usually grease and oils. These stains are best cleaned by surfactants. And finally, the last category that will be talked about is the particulate stains. These stains are typically mud, soil, and dirt stains. Particulate stains are best cleaned by using detergents, which include chemical compounds called builders. With that said, let's test these theories. To test out enzymatic stains, I grab a piece of chocolate and let it melt on a piece of cloth. Unfortunately, the wind was not on my side, so after around 5 minutes, I took it inside and drew a smiley face. So to try to eliminate the stain, I used a cleaning detergent which contained enzymes. This stimulated the process of removing the stains. So what's actually happening here? Well, the enzymes are actually breaking down the multiple starches, fats, proteins, and oils in the stain. And as you can see here, it completely removed the stain. Another thing to note is that detergents that contain enzymes are also referred to as biologic detergents. This is because they contain lipases and proteases, which actually can also be found in the body, therefore biological detergent. So what do lipases and proteases do? Well, lipases are what help break down the liquids such as fats and oils, and proteases break down protein, which are usually what make the enzymatic stains very tedious. Next is the oxidizable stains. Let's take the example of coffee. Now, bleach is great for this situation because of it being an oxidizer. When bleach is applied to the coffee, it goes through the process of oxidation. There are two different bleaches you may have: a chlorine-based bleach and a hydrogen peroxide-based bleach. Hydrogen peroxide is a chemical compound mainly consisting of oxygen and hydrogen. The hydrogen peroxide is considered an oxidizing agent in the bleach, so when the bleach is applied to the stain, not only does it disinfect the material, it adds the element of oxidation, which removes the electrons from the chromophores, which is fundamentally what gives the stain the color. If you're using chlorine-based bleach, the chlorine reacts in a way with the water where it produces oxygen and hydrochloric acid, which also reacts with the chromophores by terminating the electron in a molecule. This leads to the color change, rendering the stain invisible. Unfortunately, I could not test this because bleach is actually a very harmful chemical, so yeah, I wasn't allowed. Next up are the greasy stains. These stains could easily be removed with enzymes, but can be removed more effectively with the addition of surfactants, which are also known as surface acting agents. Surfactants are most commonly found in many soaps and detergents, so it won't be that hard to acquire. So to test this out, I acquired a different cleaning detergent and used it for this example. To display the removal of greasy stain, I used some olive oil on a piece of cloth and let it sit for a bit. Just to verify that it was actually stained, I put it under water, and as you can see, a region of the cloth has been stained. So afterwards, I applied the detergent to try to remove the stain, and it looked like it worked, but to be sure, I let it dry, and as you can see, it's clean. So why did this work? Well, this is because of the surfactant content of the selected detergent. You see, surfactant molecules consist of two parts, a hydrophilic head and a hydrophobic end. When the surfactant solution is added together with the water, the hydrophobic end tries to stay away from the water, and as you can guess, it's the opposite for the hydrophilic region. As this happens, the surfactant forms circles like so, which traps the oil and grease in the middle. This is what is called a micelle, and as you can see in this image, this is what micelle molecules actually look like. Now, with this formation, all that is needed is to rinse it away with more water. Another thing to know is that it's even easier to rinse away since oil is hydrophobic in the first place. And lastly, we have the particulate stains. Just to remind you, these are typically dirt, soil, and mud stains. So as you may have guessed, to test this out, I quite literally went outside and rubbed a white cloth on the floor to produce a stain, and I might have taken it a bit too far, but it's for science. So after that, I went back up and used our usual day-to-day detergent, which contained chemical builders. Chemical builders are used in detergents as they stimulate the process of surfactants. But not only do they do that, but builders actually help soften up the metal ions such as calcium and magnesium, which is what bonds it to the material, making it harder to remove the stain. The chemical builder helps resolve this issue, then the stimulated surfactants take care of the rest of the dirt, and as you can see, you're left with a clean material. To wrap things up, stains are a pain to remove, but if you understand what can effectively remove a stain, your life will be a lot easier. Some stains can take forever to be permanently removed, but with the help of chemicals like surfactants and oxidizing agents, the pain of removing stain can be eased. With that said, there are still some stains that deserve just to be thrown away.